Good day. Welcome to this episode of the X-Celerate webinar series. My name is Jessica Prince, and I'm a solution architect with IS Cubed. In today's session, I will be introducing you at a high level to AVEVA's Asset Strategy Optimization, which is a decision-making solution to identify and justify the asset strategy that helps you deliver the maximum economic return on assets, reduces costs, optimizes asset performance, reduces unscheduled downtime, ensures safety, improves quality, and demonstrates compliance. But first, let's take a look at what maintenance would look like in a perfect world. In a perfect world, where there is unlimited time, unlimited budget, and unlimited resources, we will have no maintenance management issues. However, we're living in a world where we are constrained. We have limited budget, we have limited time, and we have limited resources. So my question is to you, what is the best strategy that you can apply to your business in your current climate? As an industrial company, your target of maximizing the return on assets and achieving the perfect balance between risk, cost, and performance can be achieved through an optimized asset performance management strategy. So let's take a look at what an optimized asset performance management strategy looks like. The first step in adopting an optimized asset performance management strategy is risk-based maintenance. Risk-based maintenance, by its definition, is a structured approach to identify and justify an asset care strategy that ensures that business objectives are met. Running assets to failure in order to reduce maintenance costs can lead organizations to run in a firefighting maintenance approach, where resources are always engaged in urgencies and unplanned outages impacting the production outcome. The opposite is being in a comfort zone with high preventative maintenance rate leads to excessive costs due to unnecessary interventions and asset replacements being carried out to ensure production continuity. The objective of an asset strategy is to find the optimal mix of maintenance strategies which balance the risk versus cost and performance. It is finding the sweet spot in over-maintaining and under-maintaining your assets. Finding the sweet spot and having it adopted by all departments is a journey. With every journey, it starts with the first step. If you're coming from a firefighting maintenance mode, a good first step is to determine which assets are really important to your organization. A good basis for making this determination is to set strategic business objectives, which are the key goal. These same business objectives are the starting point for setting up your asset strategy and AVEVA's asset strategy optimization. The business objectives are combined with the likelihood of failure calculated from the mean time to failure and brought together with the risk matrix overview. AVEVA's asset strategy optimization is the starting point for any digital transformation journey. With AVEVA's asset strategy optimization, you can build an asset strategy where you can carefully balance the risk, cost, and performance of your asset. By deploying a risk-based maintenance strategy, you can better understand which maintenance technologies to deploy based on the risk profile of your assets. A risk-based asset performance management strategy where you know which are the critical assets to your business and what risk factors are involved should those assets fail. This is the starting point for any digital transformation. KPIs like availability, reliability, maintenance cost, and safety and compliance will be carefully balanced against the risk of failure of your assets. AVEVA's Asset Strategy Optimization offers reliability-centered maintenance, RCM, FMICA, root cause analysis, simulations of different maintenance scenarios, and inventory management. Now, let's take a look at what an optimized asset strategy looks like in terms of the overall APM solutions that's available within the AVEVA portfolio. So let me just take it through a continuous improvement approach. A maintenance strategy is subject to change due to changes in the market imperatives like product demand variations, external disruptions, new regulations that may affect your business goals. Once the optimized asset strategy is defined, this can be executed by maintenance teams and recorded through EAM systems. This can then be easily integrated with AVEVA's operational safety management and AVEVA's mobile operator rounds, which will be covered later on in the webinar series. The operating assets will then be monitored to identify health insights that may affect the maintenance to be executed and the strategy to be refined over a period of time. Depending on the strategy applied from condition-based maintenance using the AVEVA Pi system or applying predictive analytics using the AVEVA's predictive analytics solutions. Both of these products will also be covered later in the webinar series. Then on a regular basis, the asset strategy should be analyzed through a lifecycle costing evaluation for you to identify any bad actors during the period. The return on experience will finally be capitalized to an RCA and a strategy improved through scenario comparison for running a new optimization to execute from the coming period, such as closing the continuous improvement APM loop within AVEVA's asset strategy optimization. Now, let's take a look at the AVEVA's asset strategy optimization solution. So let's take a look at AVEVA's asset strategy optimization desktop client UI. So as you can see that all the modules are available because the software is a module-based solution. So depending on what you've been licensed for, you will see those modules visible on the menu bar. By default, we have the FMICA module that's opened. So when you open up the solution, it opens up the FMICA module by default. We also have the FM library or the AVEVA's Asset Strategy library, which is also an option, which is sold separately. This allows you to easily create the asset tray depending on the sector-specific failure data. So this dramatically reduces the time from creating your asset strategy from a manual entry. So you can see on the middle pane we have our FMICA or our asset structure for pop soda demo that I'm currently running. So you can see all the different levels within our structure. So you can collapse, depending on how many levels you have, you can collapse that to the lowest level. Then to add another folder, you just high click, and then the new button will display any options that's applicable to that application that you've selected. So next we'll have a quick look at the web client. So you'll use web client with any HTML5 enabled browser. So you'll see the same asset structure as you would see in the desktop client, you will see in the web client. So you could also have the library on your left-hand side. You can easily use as well to drag and drop those library options. You can also then click on the menu icon to see the different options available depending on what item you selected. You can also use the add button functionality to add different components to your structure. You also look at the user, which user is logged in. You can also change the password as well. So now let's just do a drill down into one of our structures. You'll see that the layout is exactly the same as what we have in desktop client. So you can move from, so depending on the size of your asset structure, it will take some time to load. So, but depending on how you set up. So in terms of the coloring, so normally the green is for non-critical assets. It's been highlighted in red. It's the critical assets where you would apply the preventative measures. So where it's going, you see depending on what you select, the menu will then show the relevant actions you can then perform based on your selection. So you can see we can add another item on the same level, or we can add a child item to whatever object you've selected. Right, so let's just look at, just scroll down some more, let's go into ball valve and let's see the different freedom strategies that we have added. So we have condition based that we have, so you can see that is the same as we have in the desktop client. Okay, so after we've done, so this is how easy it is to move between the different clients that's available within Asset Strategy Optimization. Okay, now let's look at the FMICA steps and how they applies to the AVEVA's Asset Strategy Optimization. So the FMICA method is commonly used in practice in the process in defense industries to perform risk analysis. So we'll see now how Asset Strategy Optimization supports the FMICA method, and we'll be explaining some of these steps. The FMICA abbreviation, which means failure mode, effects and criticality analysis, which is a quantitative analysis of the risk. This is a method that was derived from the MLSTD 1629A, which is a norm for the American Ministry of Defense. It is defined as a reliability evaluation design technique which examines the potential failure modes within a system. So we'll just go to each of these steps within the solution and see how they apply. You'll see that some of these steps, certain portions of the software covers them. So let me just take it through what they are. So these are the 7 steps. So it is a reliability evaluation design technique which examines the potential failure modes within a system and its equipment in order to determine the effects on equipment and system performance. So that's per its definition. So FMICA aims to at the signaling risk that comes forward during production processes. So risk can be reduced by implementing technical improvements and by adapting the maintenance concepts. This mainly involves mitigating risk by applying maintenance. So before we dive into the software, the user, uh, just to show you how the functionality is distributed within the software. So the FMICA functionality has been distributed over 3 different modules within AVEVA's Asset Strategy Optimization. So the FMICA system, this is where the user can construct the FMICA tree consisting of the systems, components, and the parts and the criticality data for these objects. Then we have the FM library to help you to quickly build up the FMICA tree. And the FM library can be used to define and reuse structures or parts of the structure in another FMICA structure. Then we have the simulation model. So this is where you can have scenarios that can be defined and simulated the behavior of a system under certain conditions, and the results can be displayed through a variety of reports. And the other functions that's also related to the FMICA are the business objectives. This is to perform FMICA. A risk matrix must be defined. That will be based on the business objectives and the factor classifications. The other module is the maintenance concepts. So in a FMICA is often performed to develop an optimized maintenance concept. Then we also have the dashboard module. The dashboard indicates the FMICA progress to the user for indicated scope. So now let's look at each of these different steps and how we can apply it in the solution. Now let's consider the following. So we're going to look at the first step in the 7-step process. We're going to look at the boundaries and decomposition and the functional disruptions. So now we have a circulation pump. What would be the best maintenance strategy to apply to this pump? So we're looking at the application, the design, and also the designation of this pump. And now we have broken down the pump into different components. We have the motor, gearbox, couplings, and the propeller. And we've also listed the different failure that can occur within the different components. So let's take a look at how we can create this FMICA structure within AVEVA's Asset Strategy Optimization. So the first step to do is to create a folder within AVEVA's Asset Strategy Optimization. So we right-click, we can say New. We will rename our folder. For this example, we'll use Plant 1 as my folder, which is the lead test, and then rename it Plant 1. We'll then right-click on a folder we just created. Then we'll create a serial subunit to provide an asset name, which is going to be underneath our unit, which is going to be our plant sub. So we're going to have the folder structure. We're going to have then our unit. Then after we have created our unit, we'll then add our circulation pump. Okay, so we right-click on New. We will say Unit, and we'll rename this to Plant Sub. So just bear with me. My demo environment is a bit slow. Right-click, give it a name. So we'll say, Plant Sub. After we've created our plant sum, you can also see the different options available if you right-click on your folder structure on your left-hand side and also your right-hand side. So you'll see the different menu options available. Right, so now we go back, we'll right click and we'll say new, we'll create an assembly, so you see a subunit. We'll name this circulation pump. Then if you have the tag numbers available, you can also add the tag number, and then the tag number will be automatically added to your serial subunit. So after we've created our serial subunit, we will then add the circulation pump. So we'll right click new, we will say assembly. So depending on your resources, if you allocate it to your machine, this normally takes that line. Okay, so you create your assembly. Okay, so after we've created our assembly, we then create the different components as well underneath our pump. So we'll create the motor, we'll create the gearbox. Then after we've done, we will then later on add the failure modes to the different components as well. So now we're going to say circulation pump on our assembly. So the normal process is to right click and add new. As you go down the different levels, only certain options will be available that's applicable to that level within your asset tray. Okay, so we've added the circulation pump. Okay, so we click new, so we'll see the different options available. So component we're going to add. So this is where we add the component level to our asset structure. So you can also copy and paste the different components and just rename the description in the property window as well. Just save some time in terms of adding a different descriptions or different components. And as you can see, as you go deeper down the levels, depending on how far you have created your structure, you can expand it to that different kinds of levels. So in terms of if you're doing this manually, it normally takes, depending on your asset structure that you have, that normally takes a while to create this manually. But if you have the asset strategy library, you can easily drag and drop those applicable asset libraries to your environment. This then enables you to will save you time in terms of you doing this manually. So we're going to add the gearbox. Okay, let's just say new. Okay, so like I said before, we can just copy and paste the other components. So right click and then we'll copy and paste. And it's just waiting for my start. Okay, so let's just copy and then we'll paste it. So you have to, when you're pasting, you have to make sure that you paste at the right level. So when the components will be listed underneath the level that you've selected to paste under. So then we can just easily rename the descriptions in the description property pane. Okay, so we'll change that to primary coupling and we'll say it's going to be high speed. We may click on the gearbox and we'll change it to propeller. Click the pump that has been added. Okay, so now we're going to add. So now we're going to another level down. We're going to right click. We're going to say new. So depending on which level, like I said before, depending on which level you select, only the applicable items that you can add on the level will be available in the context menu. Right, so I'll add the failure. So let's right click system, and then you can also copy those failures as well, and then copy and paste it on the other different components as well. So we'll rename This is going to be the failure mode. This is going to be for the bearing. So we'll type it in. So you can easily edit these text fields once you want to make a change. You can also see the different options available, like the mean time to failure, the failure types. All of that is also available in the properties of whatever item you select in the middle pane. Okay, so we've done that. So what I'll do now, I'll copy and paste the failure modes for the rest of the components, just to speed up this process. Okay. So whatever other properties that you have also defined, it will also be available in. So for this, but we're gonna say that it's gonna be because of way. So we're gonna add way on our defect bearings. So once you've added that, right, so you can see how simple and easy it is for you to create your own customized structure, which is applicable to your environment within AVEVA's Asset Strategy Optimization. So like I said as well, using the FM library saves you a lot of time in terms of completing your asset structure. So I've copied and pasted all the failure modes, and then I changed the property description on all of those. Okay, so let's move on to the next stage. Okay, let's take a look at how we add the business objectives within AVEVA's Asset Strategy Optimization. So you have to select the unit on the leftmost pane to enable the business objective module. So you will see now as I'm showing you. So it's only available if you select the FMEGA structures on the left-hand side. If you select any item within the middle pane, it's not available. You can add up to 6 business objectives for one FMEGA project or folder. So the selection options is determined whether or not the values of each maintenance action is part of the component or system, which is determined for the maintenance time and also the response time fields. So you can look at the downtime and risk calculation options as well. And all these fields are text-free fields where you can easily edit it adjust to your requirement. You can also set a default to determine which effect on your business objective is populated by default as a standard risk threshold within the FMEGA grid. Now let's look at the third step in the 7-step process of the FMEGA system. So now we're going to define the classifications and weighing factors. So for FMEGA, it's a common practice to create classifications for the time periods, mean time to failure, and repair durations, and to link these to the weighing factors. The weighing factors define the importance of certain failure causes for one of the business objectives. This mechanism is called a factor classification. So the classification is performed on a system level. An example is what I'm going to take you through now. So it works on the same as the business objectives. So you click on business objectives and you select the classifications. So you see we have the 2 options available, repair duration and mean time to failure. So defining a classification consists of time periods defined in hours, weeks, months, or years, and a weighing factor, any number, which is also included. The time interval always runs from a certain point in time up until and including another point in time. So if time is 1 is greater than x, is then also then greater than times 2. So the time interval will automatically be adjusted to the newly entered time values, so they will always be connected. So they follow on one another. So to create a factor classification for the system, you open your FMEGA system screen. You select the FMEGA system you want to configure the classification. You right-click on the FMEGA system, and you select the factor classification. And in the quick menu, then you will then see this the screen as you see now. That's displayed. So then you will choose to either the mean time to failure or the repair duration that you will then select Okay, let's continue the steps. So now we're gonna define the failure behaviors of each of our failures within our asset structure. So for this, we're gonna open up our asset structure. We're gonna select our failure modes. Then we're gonna add our failure behaviors. So I have a list of failure behaviors that's going to be copy and pasted. Within you can see that they are available in the properties pane of our solution. Right, so you have to select your failure mode, and this is only available for us. There's multiple ways of selecting or to see the properties of a failure mode. So we select the failure, and then we're gonna add the behaviors. So you can see in the bottom, there's the functional failure that's available. So now we're going to select another one. It's an example. So you'll see there's an edit button. So with the edit button is where you can add those failures to a list of failures. So you click the add button, and then you're going to individually name them. So it's a text field. So with this one, we're going to say that this is going to be copying and pasting. So first, in a name property. This so we have from the list we have leakage, this one. We have loss of production as well as one of the failure behaviors that we have. So let's just add. So I'll only add a few and then fast forward the video just for the add of for the sake of time. So for this, we have insufficient load. No, insufficient and no output. So we're going to say, okay. We can then easily edit or add that failure mode we have. Okay, so now once you've added the failure mode, you can see other properties that's also available. That's applicable to this failure mode. So now we can essentially assign those failure modes to our business objectives. So there's two ways of doing it. So now I'm showing you a quick way of doing it. Then we also have the option, which is the GUT functionality, the fixed GUT. We will be covering that later. In one of the videos, this is where you have a complete view of your different business objectives and then the classifications of your failure modes on those business objectives. So now we're going to add. So once you add the other failure behaviors, you will see that they are saved in a list. And then depending on your failure mode, you can then just select the appropriate failure behavior for that mode. Okay, so we have leakage and we're also adding no cooling. This one, say okay. Now we can select any one of the other failure modes and then we can just select the list and then select the appropriate option that's available, that's applicable to that failure mode. Okay, so once we have added our failure behavior, we can now add for the other ones. So just click. Okay, so once we've added all the failure behaviors, we're going to move on to the next step. Okay, now we're going to find a failure in terms of the business objectives. So this is where we're going to look at the flex grid. So now using the flex grid, so you have to select your component. So you can either use the quick option on the top to select the flex grid, or you can select on the component level or your unit level. So we'll right click and it will open up flex grid, and it will open up, and then you can assign your classifications based on your business objectives. So after entering a failure data, the next step is to define what a fixed or failure will have in your business objectives. So this data can then be stored or is stored in the FMaker grid. The FMaker grid presents an overview of the parts that are present in the selected system. So for each part, an overview is presented, and also the failure modes as well. So next to each of the failure modes are a number of columns that can store the effect on the business objectives. The number of columns is equal to the number of business objectives that you have defined for the FMaker system. Per business objectives, a choice can be made among the classes that were defined, and then in each of the columns, each business objective, the effect of the failure, and also on the level of the subsystem can be entered. With the data in the FMaker grid, gives you a comprehension of how failure affects the business objectives, as it also that failure increases. Getting into customization of the asset strategy for some specific asset is still a needed step, and our flex grid selection helps making bulk data in a user-friendly format, giving you a full overview and filter capabilities for the reliability-centered maintenance data. We see here how the asset failure causes maintenance. We see here how the asset failure causes the maintenance strategies and the effects on the business objectives are classified and can be rapidly modified without the risk of misalignment due to paperwork or worksheet practices. So I'm going to add a few, and then we're going to forward the video we have added the complete list of for the classifications. So now double checking my effect for the cost on what the leakage will have in terms of the functional failure. So we're looking at the functional failure, and then the classification we're adding to those. Because you can see it's a very easy to use user interface where you can then easily select those classifications. Okay, so I've added the field. You can also save this and also come back and make changes as per your requirement. You also have an option to view the columns to have it in descending order or ascending order as well. And then you can just update the relevant values per column. And so select. Okay, so for this one, we have the loss of capacity. We add it. So completing the FMaker grid or assigning the effects to the business objectives is one of the requirements before you can actually complete or to use the risk matrix functionality within the solution. So this is one of the required steps for you to get to the point where you can actually use the risk matrix. Okay, so we've added all the right fields. And now we can go to the next stage within the FMaker process. So next we're going to look at defining the risk number and the risk threshold on the risk matrix. So after filling in all the failure data, it is time to have a look at the risk. And the risk is indicated by means of a risk number. This number is the product of the weighing factors of the mean time to failure or the repair duration in the classification of the effect. So whenever the risk exceeds the set threshold, the risk threshold, the part in question will be considered the critical. Calculating risk numbers is done automatically by AVEVA's Asset Strategy Optimization, and the result of these calculations are visualized in a risk matrix, and we will see what this looks like in the software. Okay, so defining the risk number and looking at the risk threshold. So, like I said, after you fill in all the failure data, it's time to have a look at the risk. Okay, so you'll see that the system automatically calculates the risk for us, and you can visually see what it looks like in the risk matrix. So you also have an option to change your business objective and to see how that will impact your risk matrix. So I'm just giving you a high-level overview of the risk matrix functionality that's available in the software. So this is all visualized based on the data they've entered into AVEVA's Asset Strategy Optimization. So depending on how big your asset structure is, it'll take not that much time, but it takes some time to load or change between the different objectives in terms of loading the risk matrix. You'll see the best number on the top in the risk matrix, and you'll look at from this, then you can decide depending on the risk, you can then decide which asset strategy to actually implement. So the top line of the risk matrix shows the classification of the mean time to failure, and the second row shows the classification of the repair duration. So it is repeated for each of the mean time to failure classification. So the column on the left shows the classification of the business objectives, and the matrix cell shows the risk number as a column of 3. So the topmost number is the risk number. The middle number indicates the number of combinations of the risk of the failure mode, and then the failure cause and failure conditions that ends up in the cell as a result of the risk calculation. The lower number indicates the number of combinations of a failure mode, a failure cause condition, and that ends up in a cell as a result of the risk calculation performed in a chosen scenario, if you have any scenarios that you want to link to your risk matrix. So this number is 0 if no scenarios have been defined, and working with scenarios is part of the simulation that's also available within AVEVA Asset Strategy Optimization. We will not be taking you through that part, but we can look at all the other functionalities also available in the solution. Okay, so once we have done the 7 steps of the FMICA, we're going to look at on a high level on the other different functionalities that's available within the solution. So one feature that's available is to interface to different existing EAM systems if you have on site. So like those will be listed, like SAP, Maximal. We also have a option to do CSV extractions for sharing data, and this functionality can be used to import an asset hierarchy and also import or export a maintenance plan up to the task list. This will avoid any inconsistency during manual entries. So making sense of raw data values is nearly impossible, and this will take a lot of time to figure out how to build a model, much more so than 20 minutes. So as a performance reliability maintenance engineer, you have the history trend to look at trends and find out what is wrong with the information. While this is possible, we have to agree that even the brightest engineers will miss correlations in the data because there's so many combinations of data to look at. And the system makes it easy. So now let's look at other features also available within AVEVA's Asset Strategy Optimization. So in terms of determining the criticality of assets and dormant failure causes. So here we can see the asset structure has been imported from SAP PM, system with added failure causes and maintenance inspection task. The criticality is then run through with the FMICA functionality, providing insight into asset failures caused impact on the business objectives. So the risk is provided by the effect times the probability of the failure. In this example, we can see some failures are in the red area, meaning that the associated risk should be mitigated by adding a strategy action to either reduce the occurrence and moving it to the left direction, or to reduce the consequence, moving the failure to the bottom of the risk matrix. To be able to identify and apply the right strategy, our operators or owners need to have the following steps. They have to have insight in the install base. What assets do I have? It seems like a strange question, but sometimes that is not completely in the EAM or the CMS system. AVEVA's asset strategy optimization supports setting up, completing the asset hierarchy with every asset that they have in it, even to export it to a CMMS or EAM system, if it is desired. The purpose of having the entire asset hierarchy in a CMMS or EAM system is to enable register is to enable the registered failures on the right asset, bad actors, and failure registration. And B, to be able to assign the time-based preventative inspective task. So this is varying from regulatory or legislation or OEM prescription or whatever justification is used for that strategy. Creating insight from functions of assets. So this is the role of the asset in the operational process and the effect of the functional failure mode. What happens if the asset is not functioning according to the core function? This would indicate the criticality of the asset. Right, so after we've done that, we can look at design maintenance strategy based on the criticality templates. So the speed of deployment of a risk-based strategy, the failure modes and maintenance strategy can directly be dragged and dropped from AVEVA's asset strategy library to gather the best practice and to share them throughout the enterprise. A customization of the templates and specific asset could also be included. You can also mark them as mandatory maintenance activities, and the task list is applicable as well. So you can see that this can be included in the solution. So based on the criticality prioritize deployment of a strategy based on the equipment failures, failure modes, different kinds. Design a strategy that provides the right care. This is what to say the risk-based strategy, not optimized, just covering the risk, whatever indicates of the risk. In a failure mode analysis, parameters for downtime, cost, and labor consumption are assigned, which are inputs finding the optimized balance strategy, not over maintaining or under maintaining. This is what we name optimization of the strategy. Okay, so let's move on to the next functionality. So we can see that it's easy to drag and drop from the AVEVA's asset strategy library. So looking at the strategy for multi-year life cycle. So to further optimize the risk-based strategy is to carry out analysis throughout using the simulation. The affected failure modes analysis parameters like downtime, cost, and labor consumption have an asset lifecycle. Here we have a simulation to run over 50 years of the budget forecasting, including all the preventative maintenance, inspections, unplanned costs due to repair, downtime, and production loss. So a multi-year budget forecasting includes preventative, some of small frequencies. So we have some inspections, could be small frequencies as well. Unplanned costs, repair cost, which is typically higher than planned events, but also looking at the cost for downtime and loss of production. So the claims or any compensation that's also works with that. So this is all depending on the market dynamics. So predictions are taking place based on inputs in the operational properties, failure modes, and maintenance tasks, which could be corrective or proactive. So we can look at the predictive resources requirements that we just spoke about, and looking at different failure modes as well. So a multi-year cycle. So the aim is to find the optimized balance strategy, not to over-maintain or under-maintain. We clearly see here that neither full preventative maintenance is in blue or the full corrective maintenance approaches in yellow are the best ones. So the first has a high maintenance cost, the activity associated with it, while the second is impacted by high repair cost and production losses due to breakdown approach. So looking at building our comprehensive business strategy scenarios as well within the simulation. So we can look at predicting and optimizing the year by the OPEX expenditures. And we can also see that in general, um, the costs for unplanned are higher per asset than planned. Even within inspected aging, an asset can run for a while, but then be repaired in a planned manner as well. Okay, so this is an example. So our risk-based maintenance strategy here in yellow shows improvements on both total cost of maintenance. So this is the task divided by task or duration. They can be further optimized. As seen in the green scenario, thanks to the identification of the most impacting failure causes provided by the tool, so that these can be mitigated to achieve the perfect balance in your strategy. So ability to compare different strategies, as you can see within our solution. Okay, looking at the spare parts optimization and for reducing the impact of downtime affecting plants availability, it's important to optimize your spares part strategy. This can be easily done through solution thanks to the clear identification of stock candidates for critical spares by the visualizing the impact the reduction to the downtime risk when putting them on stock. The interactive charts guides the user to clearly identify the changes on the asset strategy. So as we can go through and we can look at what's available in the spare parts optimization. Then looking at RCA. So the RCA module allows creating root cause analysis to the reliability engineers, including reports, problem, either human behavior analysis. It provides an event map showing all the nodes of the incident in a graphical way. This shows that events occurred. This shows that what events occurred, which were the causes and effects, which barriers were present at and led the setting actions to be implemented to avoid incidents happening in the future. The solution then can be exported. The solution can then can the solution then lets exporting those actions for corrective execution, and can also be integrated with maintenance strategy for the following period, such allowing knowledge share at the enterprise level as well. Then we're looking at the user dashboard. So all shown, as you can see in the image, the user dashboard is a customizable widget selection where you can rapidly visualize the life cycle cost over a period, and the PM can remove from the non-critical failure causes, or at the opposite, you can then check the maintenance strategy types, which is adopted for the critical ones, and balance between the corrective and preventative maintenance. For this view, you can then have a field overview of the APM strategy at a glance to take rapid and objective decisions to deliver on your continuous improvement process. So we have the failure-based maintenance, we have the use-based maintenance, condition-based maintenance, and the right widget shows the amount. The right widget shows the amount of failure-based maintenance actions against the mitigation types, which is condition-based actions. The key is to mitigate the failure-based maintenance by introducing condition-based or use-based maintenance. However, non-critical failure-based maintenance is not necessarily needed for mitigation. So you can see on the widgets which is available. And that's all I will be covering in this introductory session, looking into AVEVA's Asset Strategy Optimization. To find out more about the full AVEVA portfolio, details is available on our website, which is www.is3.co.za. Thank you for joining me for this session.